Hello, and welcome to this introductory tutorial on the Scene Optimizer toolset, a suite of tools built to help optimize your scene data and improve interactive and runtime performance. We will cover how to find the tools within Omniverse, go over the UI, and explain the various processes available, and how we can combine them into a preset for later reuse. We will also walk through a sample scene showing how the tools can boost performance and improve your workflows. As of Kit Release 104.1, the Data Adapter toolset has been renamed to Scene Optimizer. So all the references in this video to Data Adapter will work just the same as the new Scene Optimizer name. Let's open up the UI window for the Data Adapter toolset. It's under Window, Utilities, Data Adapter. This window will pop up. We can see that we have a bunch of different options. We will have Load Preset, Save Preset, Execute All, Clear All Processes, and Add Data Adapter Process. We click Add Data Adapter Process. We have a new submenu that allows us to add any process that we would like to run on our data. Let's try Merge Static Meshes. When we have this, we were able to bring up a new window that shows us all the available options. We are now going to add objects to data adapter processes. In this example, I'm going to use the Merge Static Mesh process, but this user flow will be the same on all processes available in the toolset. We can add a mesh to our list we wish to process by selecting the object in our stage, then pressing the Add button in the UI. To edit our list, we can click on the Edit button, which will bring up a new window where we can select and add additional objects to our process. By default, if we leave the list field blank in any data adapter operation, it will process everything in the scene at the root of the current stage. If you want to create a new namespace for the prims in our process, we can define a new output name here, and we can see when I run the process, our result is now called Merged Mesh. We have many other processes available that can be used in either a single process or combined to make additional performance optimizations depending on the contents and complexity of your source data. You can see a list of the available processes shown here, and we will go more in depth in another video about each process and their configurations. For now, we will show the usage in the sample scene. Here we have a sample scene that's been provided to us by LOTUS SD Digital Factory team. As you can see, it's a pretty complex scene that has a lot of different moving parts and a lot of duplicated geometries and animations. Here we have a baseline of what we can see when the scene is not running. As we run the scene, we can see that the frame rate is really slow, and we can see that it's not taking advantage of any of our deduplication processes, our merge processes, or our optimized geometry processes. So let's see if we can fix this scene. So let's open up the Data Adapter toolset. Knock it over here. So let's add the processes we want to run. First, we're going to deduplicate the materials. And then we're going to optimize skeletal roots. Then we're going to merge static meshes. First, we're going to use optimize materials to deduplicate all the materials that are in our scene. We're going to use this operation to help inform how we're going to do some of the merging in our merge static mesh operation. The method we're going to use is deduplicate. This method is going to help deduplicate the materials in our scene that we have many instances of, where we can create a deduplication and point back to a single instance of the material throughout our whole scene so we can get that optimization without having to traverse all of those extra instanced materials. Next, we're going to use the optimize skeleton roots process. This operation will merge all meshes for meshes attached to a skeleton. This can greatly improve character playback and speed by optimizing scenes for GPU scaling computation. This is good for this scene because we have robot arms that have skeletal animation throughout the whole scene in our instance. And so we have multiple instances of those skeletons, and this will greatly improve our performance. Lastly, we're going to use the merge static mesh operation. This reduces scene prim count and can improve overall stage performance. Note that because the total amount of geometry does not change, this option will not reduce memory consumption very much. Also note that once merged, you cannot edit the individual meshes, just the newly created merge mesh prims. I'm going to leave the defaults on all of these, and I'm going to execute all in the process stack, and then I will come back with the updated results. Now that we have our optimized scene loaded, let's see what some of the statistics are. Navigate to Window, Utilities, Statistics, and then I'm going to go to RTX Scene. I can see a baseline of what optimizations we've made. As we can see here, the meshes have dropped to 8,463. So we already have a massive improvement there. We also have deduplication on the RTX rendering side to 2,408. So let's close this. Now we can see our scene here. We're going to play back and we're going to see what kind of frame rates we're going to get from the optimizations that we updated from the data adapter. So you can see we can have a much higher frame rate playback than our original scene. The capture here is taking down the frame rate a little bit, but we're hitting almost up to 30 frames a second from our original 2 frames, which gives us a massive improvement in performance. And you can see that we've made new flattened mastered merged materials for each of our optimizations on different meshes we wanted to run. So here we are in a different view where we can toggle around and see kind of what's going on in this scene. Again, we have improved playback performance. Let's go over how we can save a preset from the process stack that we've just created. I'm going to go to Save Preset, navigate to where I want to save it. Let's name it. I'm going to name it kind of the different process stacks it's going to be here. Save. Now we have this saved, and we can clear all these processes. If we want to load back up a new preset, we go back to it, can navigate to where we just saved it. We have all our configurations that we can use at a later time, or on other scenes, or share with other team members that we may have. Hopefully that helps in learning how to save a preset. Thanks for following along in this video. Hopefully we have shown you what some of the data optimizations are available within Omniverse. Please look to our documentation online for more information. We hope to see you in the next one.